2 for our videos today is about using linear equations to make predictions. And so the idea here is the equation doesn't just tell us about some points, but it tells us about a lot more points. So with that, I'm going to jump right into our first one. And the scenario is this. The cost of an Uber is modeled by this equation, y equals 0. That's a 0. 0.5x plus 3. And so in this equation, x is going to be the number of miles that we are traveling, so how far, and then y is going to be the cost in dollars. And so the first equation or question we have is how much will a 20-mile ride cost? And see, the idea here is that we recognize that 20 miles is going to be our x value. And so what we can do is plug that 20 mile into our equation, putting 20 in for x. So if we have y equals 0.5, I like to always substitute with parentheses. So in my parentheses, I'm going to put 20. Okay. So at this point, grab a calculator, multiply it out, not a big deal. But if we go through the work for this, we get that y is equal to 10 plus 3, or y is equal to 13. And if we use the context of what our variables mean, we can be specific and say that the cost is $13. I made up these numbers. I have no idea if this is right or reasonable, but I just wanted to give a ballpark. And so in this particular equation, we have made a prediction of what that 20-mile ride would cost. On the flip side, I could change the question around a little bit, and I could say, you have $20. How far can you travel? And the key here is to recognize that if we're talking about dollars, I'm no longer looking at x, but now I'm looking at y. So in this case, my 20 is going to be equal to my y because my units are now the dollars. So when I go to my equation, I still have the same equation, but now I'm going to replace y with 20 and then have the rest of my problem, 0.5x plus 3. And I'm going to solve like normal. So I need to subtract my 3 to the other side. You've got 17 is equal to 0.5x. And then you're going to divide by, let me move that up a little bit, 0.5. And again, totally fine to use a calculator. And if you get that answer, you're going to get that x is equal to 34 miles. And so the distance we can travel is going to be 34 miles. I know those are the right units because I was getting x by itself. Okay? So in both of those cases, we had the formula and we were using that to make a prediction for one of our other two variables. There's one other scenario. This would have been in chapter 4 last year, 4 or 5. I don't know if you guys saw this, but most of the time when we're talking about linear equations, we have what's called a scatter plot. And the idea behind a scatter plot is you've got a few data points and you want to talk about more than just those data points. So in this particular example, it says below is a scatter plot that tracks house size and cost. Okay, so if we look, there's square footage at the bottom. It's going from 500 to 2,500. Most houses are probably between 1,000 and 2,000 in this area for a ballpark. And then it says cost in 100K. So obviously the 100 right here is not $100. It would be $100,000 and 200,000 and so on. Again, I just kind of made up these numbers. When we're dealing with a scatter plot, we need to take all of these points and come up with one line. And the way we do that is we draw what's called the best fit line. And there's a fancy calculation you can do to draw that best fit line in, but essentially what it means is to be in the middle of all of your dots. So you want some dots above, you want some dots below, and you want it to feel like it's pretty much in the middle. So if I came to this particular graph, I would probably draw in a line roughly here. Okay. I probably could have done a little better on that line, but I'll take that. And the idea is there's some points that are below the line, there's some points that are above the line. I didn't have to hit 200 on the y-axis. My line's probably a little bit high right now. But the idea is this line in blue is in the middle of all of my data points. There's some points above, there's some points below. Okay, now that I have a best fit line, I could write the equation for that. We're not going to this time. We are just going to estimate the cost of a 2,500 square foot home. So I'm actually going to extend my line a little bit. Okay, and so what I'm going to do is if we want to estimate the cost for a 2,500 square foot home, I'm going to start at 2,500 and I'm going to go straight up to my line. And then once I'm at that line, I'm going to go straight across, bearing in mind that my graph is hand-drawn and drawn quite quickly. And we can now read our estimate. And so I'm actually going to take note and see that my red line over here is a little bit above 400. Not tons, but it isn't hitting exactly at 400. So my estimate for cost is going to be $405,000 because I'm just going to go a little bit above 400, something nice. And you could give a few different things. If you gave me 400,000, I would take it. If you gave me 410,000, I would take it. We will see some instances where we write the equation in this piece, but the big idea is once you draw on that line of best fit, any value on the x-axis, I could go up to the line and then make an estimate for the price. Any starting value on the y-axis, I could go across to my line and then make an estimate on the square footage. And it's not saying it's going to be perfect. A prediction is just an estimate. Obviously, the better your data, the more accurate it may be. But at the end of the day, it's just an estimate.